Hey peeps, it's James Buckle of Engage Pixel here with another little Gamemaker tutorial. This time I'm doing a Shroud and a Fog of War, which we can see working here in this little strategy game prototype I've been working on. The Shroud is the black area, which denotes anywhere where you haven't been yet and so you haven't discovered it and don't know what's there. And then the Fog is the grayed off area that shows where you've moved out of range of somewhere, so you no longer have line of sight to it. And so you can no longer see exactly what's there, you only know what you knew when you were last there, kind of thing. Now, I'll take a moment to clarify my terminology, because different games have slightly different ways of talking about the Fog of War. Some games, they just have a little black area that we have here, and they call that the Fog of War, and then they don't have this fogged off area. I call the black area the Shroud and the grayed off area the Fog because that's how I learnt it when I was working on Total War, and that's how they do it. Now other games will call it something different, but for the sake of this tutorial I'm going to be calling the black area the Shroud and the grayed off area the Fog of War. So how does it work? Well, basically you create a grid of cells that fills the room. Each cell then contains an alpha value which matches how much of the shroud there is in that particular location on the room. Each cell starts at 1, which is full alpha, so everything's complete. So the shroud is completely opaque and you can't see what's there. As the player moves around, they clear the cells and we replace the value with 0. So the alpha is 0 and this area is clear and you can see what's there. As the player moves around and then uncovers more of the room, they clear more of the 1s, and those 1s become 0. And the previous 1s all become 0.5, which is then the fog. Once we've created this data, we can then interrogate it, read it, and draw it to the room, and basically use it in useful ways. So now let's get started. I've created a test bedroom, which you can see here, and it has a red circle object and a blue block object, which I'll show you in a moment. It also has a background which has just been set to a green noisy grass. This is just so there's something in the room to give you a sense of speed. Then the basic settings for the room. It has a width of 2560, which is power 2, and then if we scroll down here, I can drag this up and get down any further. I've enabled use of views, set this one to visible, set the size to 1280 720, and just told the camera to follow this red circle object. The objects themselves, the blue block is currently literally just a blue block with nothing going on, and a sprite that's literally a 64 square sprite of blue with the origin in the top left. Now the obj red circle object, which is just simply going to be an object we move around the room that the camera will follow and which will uncover the fog and the shroud. In the create event, it simply sets a couple of variables to track the target XY position that it's moving to, and a boolean to say it's moving. In the global right pressed, we simply set the target coordinates to the mouse and XY, and then use the built-in function mouse move towards point, setting the XY and then the speed and the flag moving to true. Inside the begin step, we simply say if moving. Check the distance from XY to target XY, and if the distance is less than 10, then we set speed to 0 and moving to false. So that's the basic setup. Let's just run it and see see what it does. So here we see the red object, the red circle object, and when I right click it moves to that position. And if I move up here, we can see by a combination of the noise texture in the green and the blue blocks, we can see that it's moving. Now you notice I haven't put any collision on anything and that clicking on anything doesn't do anything, and it's just literally a basic test bed of this is it working, as it were, for checking it's working. Okay, so let's start writing some code. So let's create an object of Shroud. And let's give it a create event. And we'll start adding some variables. We need to give it a grid size 32. Spelled size wrong. This will be the size of the cells in the room. You can change it down to 16 if you like. If it's too small, you're going to create too big a data structure, and that might have performance issues, so probably less than 16 is probably too small, but 32 is fine. Then we're going to create a Shroud Grid DS structure. That's not what that function's called. So we're creating the grid, putting it into the variable Shroud Grid, and we're going to give it a size based on the room width and height. So by doing room width div grid size, we just get the whole number integer division of the room, and it tells us how many cells there are in total. And we'll do that for height as well. So now we've created a Shroud Grid, we need to clear the grid. And we're going to clear it to the value of 1, which is our default amount of alpha. So 1 will fully draw the grid for that cell. We're also going to set up a clear grid size variable while we're here, and we'll make that 13, and that will be for clearing the shroud. Now we also need to, when we draw the grid, we're only going to draw the piece of the grid that the camera is correlated to, that it is sitting over. So we need to figure out the size of the camera in cells. Now there's a little bit of a problem with this. So here's the room in grid cells, and here's the screen. Now what we need to find is the size of the camera, and we want its width going across this way and its height going down this way. Now we can do the same calculation that we did for getting the size number of cells from the room, which is div 32, and that will get this 8 by 5 that we need. Now the problem is, when we do that, so we have these cells here, we're saying there's a 5 by 8, but we move the screen. Suddenly, because the screen is no longer aligned to the grid, we have a big gap down the side and at the bottom, which means what we actually need to do is create a is get one cell more across and down so that it actually fits the camera, so when the camera then becomes aligned again, it's always wherever it moves to in the right place and will be covered by the enough cells. Because the other problem is 1280 by 720 is not actually the 1280 divides by 32 fine, but 720 doesn't. So what we actually need is a slightly different screen size. So we see here the screen is it has the extra 16 pixels that you get from the 720, and as we move down the screen here, suddenly a little bit of the bottom peeks through again, which means we actually need to add 2 to get a full enough of the grid being drawn to cover the area the camera's looking at. So we need to detect if the screen doesn't fit the grid size and add 2 instead of 1. So what we'll do is we'll create a couple of local variables and make them 1. So that's the default, adding 1 cell. But we need to check if actually it doesn't fit, and then we're going to add 1 to that, increment it so we're adding 2. And we're going to do that by looking at the division, because if it divides neatly by the grid size, then we only want to add 1. If it doesn't divide neatly, we need to add 2. And we can figure out if it divides neatly by looking if there's a remainder from the division, and we do that with the modulus operator, which returns the division. And if it's anything other than 0, then we know there's a remainder, and we know that we need to add 1 to this these variables. So we're going to say if camera get view width view camera 0 mod grid size does not equal 0. So we said that the width of this camera divided by grid size, what's the remainder? If the remainder isn't 0, then it doesn't neatly fit, so we need to increase the corresponding variable. If we just copy that and change it to the height, now we know how many extra cells to add to make it fit the screen. And now we're going to calculate the actual size of the screen in cells. So we go cam cell width equals camera gets view width view camera 0 dumph div grid size plus SOW. So we have figured out how many grid squares across the camera is, and we've added the extra 2 just to make sure that it can account for when it's non-aligned. And now we're just going to change that to height. So now we have the size of the camera. Having done that, I'm going to use this little new feature over here, the variable definitions, and I'm going to create fog on, and this will be a Boolean variable that controls whether or not to draw the fog. This way, when I now drag Shroud into the room, if I click on it, in different rooms, different levels, I want to have different variables and different settings that I can change to tell the fog to behave in different ways potentially. In fact, a useful variable to have here would be the grid size variable. So actually, if we go back to these variables here and go add and just remove grid size from there and then pop it back in there and make it an integer and default it to 32. Now if you're making a game and say you want a dungeon map, so it's kind of like a Zelda style game, you've got a dungeon, you've got a world map, and on the world map you're going to have a grid size of 16 because it's much smaller. Then you come in here, you drop your shroud in and you just change that to 16. Whereas if you were putting it into the dungeon, you might want it to be 32, so in which case you drop it in, leave it default. But let's close that and close the room and come back here. So that's that control variable set up. Now what we need to do is actually draw the fog using a draw Gooey event. So if we go down to draw and draw Gooey, we can say if fog on. So we know by using this control variable you can also turn the fog off and on the fly. So for instance, if you have like an RTS and you've got a little cutscene thing where you want to pan the camera over and show the player the objectives, then return the camera to the start position and throw the fog up, you can now toggle the fog on and off, and it'll do it on the fly whenever you need it. So now we need to get the screens, the X and Y position of the camera on in the screen, and just make it local. I've got caps lock on. Why have I got caps lock on? How did that happen? And I'm going to do the same for the Y. Then I'm going to do a div grid size to convert this position in the room into a position in the grid. So I'm going to say var pos x equals cam x div grid size. Here we go. And do the same for the Y. So now we know the position in the grid. We also need to figure out the offset position of the camera, because if it's not aligned to the grid, it's going to be, the grid can only sit on a power 2 position of 32, 64, etc. The camera can sit anywhere. It's going to be offset. We need to figure out how much it's offset by and take that into account when we're drawing stuff. So we need to go off x equals pos x times grid size minus cam x. So that will give you the amount of offset, and if we do that and change it to the Y, that will give us the offset in the Y, so we know how much it's offset by. Now I prefer to, I could for instance have put this get view x function here, and I could have put it here and that would still work, and some would argue that that way that these lines are superfluous and you can just put them straight in there and this is unnecessary. Now there's a couple of things, or a couple of reasons why I do this. First of all, when you're debugging, it's a lot easier to have all this stuff localized so that you know what every variable is, and you can see when there's a problem. You can just see what the variables are and be like, oh, okay, this is not the correct variable in there, so something's gone wrong there. It also makes it a lot easier to read by having different ideas of what you're doing separated onto a different line. So it's, I get the camera's X and Y positions, I do stuff with the camera's X and Y positions, I'm not getting it and doing stuff with it at the same time. This makes it a lot easier to read and understand what the code is doing. But also, you don't really know what that function's doing internally, performance wise. I mean, it should be a very small overhead, not a lot going on, it's just looking up the X and Y variable and returning it. But by calling it once and localizing the result, there's a much smaller overhead because you're not calling it, you're calling it twice instead of 6 times, so whatever it's doing it less because it's only doing it twice instead of 6 times. So I generally like to make stuff a little more localized into these little variables for those reasons. But if you wanted to, you could just get rid of these two lines and put them in at the cam X and Y's, and it will do the same thing. So having done this, we need to draw set color. Now I'm going with C black, which is generally the default value that a fog and a shroud will be, because generally the shroud represents the lack of information. This is the void. You don't know what's here, so it's just empty. And black is the best at representing emptiness. For art reasons, you might prefer to have a different colour in your game. For instance, if you're making a game with boats, you might decide there's a great big blue sea and you're going to use white to representing cloud or more literal fog, to just mask off what you can't see. I'm going to go with black, but you can choose whatever colour you like. We're now going to loop through the Shroud Grid. We can use 2 nested for loops to access each cell within the grid and do stuff with it. So this first line here, I'm just looping from 0 to the number of cells across, and then I'm going to nest within that another loop and this will then loop across the columns. So what I effectively have here is a loop within a loop that allows me to access each individual grid cell within the grid. So whatever code I put in here can access row R column C, that grid cell, and we do that. So I'm going to take the contents of that grid cell and make it local. I'm going to go var s equals shroud grid hash. Hash is the accessor that lets you treat this like it's an array, treat the grid like it's an array. And then we say the pos x, which is the position in the shroud grid that we're starting from, which we figured out from the camera's position up here. So we have the position in the shroud where the camera is, and that's the top left position. And we then need to offset that based on, within these 2 loops, what is the current position within that subset. And we go plus R, and we do that the same for the Y position. Like that. So now we have the value that's within Shroud Grid. Now again, you could not localize this. So see, what I'm going to do is I'm going to check. I'm now going to check that the value is more than 0, because if it's 0, we're not going to try and draw anything because it's alpha 0, so it'll draw everything invisible. Because this S value is the amount of alpha to draw the rectangle with at this position. So I'm going to say if S is greater than 0, then we're going to put a draw in here. Now you could, this bit here, this Shroud Grid thing, you could just put that in here. And if you're going back and cleaning up your code and making it a little bit more efficient, then potentially you would just copy and paste that in there. But when you're actually developing it and trying to figure out what's going on, it's better to have it in a local variable local variable here. That way, if anything's going wrong, you can put a breakpoint on here, run it, and you can see what the contents are. Because the debugger at the moment can't access the contents of a debug grid, of any data structure. All you can do is see what the internal number for it is, and that isn't useful. You can't actually currently directly access the data structure. So by putting this little s, putting in a local variable, I can actually see what value it's currently using. Now, having got that, we need to draw set alpha and use the value of S to set the alpha for the rectangle we're about to draw. We then figure out the position on the screen to draw it by converting the current cell position to a screen position. We do that with var rx equals, and we then say the current R position times grid size. So we're simply multiplying to scale it back up to the screen's position. We then need to add the offset. So this then offsets it depending on if it's not if the screen isn't aligned perfectly to the grid. We've added the amount it's offset by. Just copy that and swap it to Y's and C. We now have the X and Y position for the top left of the rectangle at this cell position. So we can draw this. So we say draw rectangle Rx Ry and then Rx plus grid size, comma Ry plus grid size, and then we don't want it to be an outline, so we say false or flays, as my typing is as usual rubbish. So now we're drawing a rectangle. There is one little problem with this though. We want to create a rectangle that's 32 by 32, and what we're saying is take the current position and add the grid size of 32 to it. The problem we have with that though is that, say the grid position is 0 and we add the grid size of 32 to draw across here, then that's actually, if you count them up, because of the extra 0, that's actually 33, and we have this entire extra column that we're drawing, or extra bit that we're drawing along the right and the bottom, which is actually bleeding over into the next rectangle. So we don't want to do that. What we actually want to do is have grid size -1 added to 0, which will be 31. So we actually need to say -1 here. And there. Otherwise what happens is there's a 1 pixel overlap of all the rectangles and you effectively draw this little grid in your fog. It's fine if the alpha's 1 because you're just drawing big blocks of everything on top of you, it's fine. But when it's the fog and it's a half alpha, it's going to draw lots of rectangles everywhere. Now the other thing I'm going to do here is when you write code you need to make your intent explicit so that people who read your code understand what it's doing. And for readability's sake, even though this works without them, I'm going to add brackets in here to just bracket off the grid size -1. Because now it's making it clear that what I'm doing with the -1 is I'm taking it away from grid size. Because before that it's just simply like it's just an arithmetic operation with 3 different values, and what's the -1 doing? If you then pass this code to someone else and they have to read it and look at it and be like, what's that -1 doing? This makes it clear that what I'm doing is the -1 is being taken away from grid size, it's not being taken away from Rx, even though effectively that would do the same thing. I'm taking it away from grid size because I need it to be grid size -1. So that's what, so you just bracket it off and then makes it nice and clear. And having done all that, we now go down here and reset the alpha. You always want to make sure you reset your anything like alpha and set color and things like that. Draw set alpha you always want to reset, because otherwise if you leave it at whatever, if it gets left at half, then whatever the next thing to draw is, it's still set to half and it's going to start drawing invisible things on the screen, and then your game will be a bit broken. So now the last thing we need to do is add a destroy event, because we need to do a bit of cleanup. So in the create event we've created this DS grid, and whenever you create things like data structures, paths from the path finding, particles, stuff like this, they use a bit of memory, and when you're done with them, they don't get cleaned up on their own. You've got to clean them up yourself, otherwise you start to leak memory, and you really don't want to be leaking memory. I didn't keep a proper eye on my memory leaks when I was making Captain Kaon, and I suddenly realised that I was leaking memory at a rate that if I left the game running, it would take about an hour and a half to 2 hours to fill up my 8 gigs of system memory. And this is a game that normally runs on about 2 to 300k of memory, and it would just sit there just quite rapidly filling up, and after a couple of hours the game crashes because I've leaked stupid amounts of memory. And I was leaking something like I think I figured it out as being like a 1.4 meg floppy disk was being filled up in about 30 seconds. And so yeah, it would just sit there just like, and like when I was a kid, that's an entire game an entire game of memory that I was just filling up in about 30 seconds, because I hadn't actually kept close enough eye on where I was using stuff and actually made sure I was getting rid of it properly. So whenever you create a grid, make sure you put somewhere where it will get destroyed. So I'm going to go ds grid destroy Shroud Grid. There we go, and that gets rid of the grid. Now I'm pretty sure that this would actually, when you close a room, when you go from one room to the next, it actually anything you were using in that room, it will get rid of it anyway. But you always still need to, even if it's just, even if you're pretty sure that that Gamemaker will take care of it for you, always try to explicitly put in a destroy somewhere for any data structures, any particles, any pathing, any of these things that use memory. And so now what we should have should work, and well, I'll save it and run it and we'll see what happens. Fingers crossed. Hey look, the screen's completely back, because of course it is. The shroud has been created and it's been filled with a bunch of cells with a value of 1, and that's drawing a bunch of rectangles. So what we now need to do is actually clear those rectangles. In part 2 of this tutorial series, I will show you how to actually clear a section of the grid as you move an object around, so that you can actually uncover areas and not just have a black screen. Here, click on me. Next video.